All right, boys and girls, let's talk about inverses today. Inverses, the main thing you got to know is switch x and y. That's the main thing. So for our first couple examples, I'm going to be sure I hit that, and then just from then on out, just default. You just got to know we switch x and y. So for our first example, y equals x squared, that's a parabola, that's the parent function, kind of looks like this. We're going to use -2, -1, 0, 1, and 2. Our y values, and you're just squaring those. So 4, 1, 0, 1, and 4. So we get this picture, 2, 4, here we go. Got that picture right there. So for my table, I already gave away the answers. We're just going to switch x and y. So it's going to be 4, 1, 0, 1, and 4. And then my x's are now my new y's, -2, 1, 0, 1, and 2. So now, 4, 2 there, 4, -2 there, 0, 0, 1, +1, 1, -1. So I have a sideways parabola, just like that. The main thing I want to spend some time doing is, yes, tables are important. Yes, reflecting across the line, y equals x, that's important too. That's how you tell something's an inverse graphically. But lastly, algebraically. The first thing we do, once again, we switch x and y. Then I got to solve for y. That's how we graph everything, solve for y. So then I'm going to take the square root of both sides. So I got the square root of x equals y, but we got to remember plus or minus, right? Because 2 times 2 is 4, and -2 times -2 is also 4. So we got to be sure that we use both plus and minus. So that's my picture there, square root of x with the plus or minus. Okay, so that's that. I'm just going to tell you for the +3, that just moves everything up 3. So a rough sketch of what the picture will look like. I'll let you kind of do everything, but it's going to look like this for this table. Then when we switch x and y, it's going to be over here. Okay, and then just be sure you do it algebraically. Yeah. So that's that one. That's 2 and 3. 3 just moves to the right 3. So your 3 is going to be here, and won't ruin what the other one does, but just be sure you're careful. Number 4 is kind of the opposite of those. So we got to talk about what the parent function looks like first. So y equals the square root of x. Zoom in a little bit there. So we have 0, 0, 1, 1, square root of 4 is 2, square root of 9 is 3. So the -3 moves all my x's, sorry, my +3 makes it a -3, moves all of them to the left 3. So -3, -2, +1, +6. My y values, the -1, moves them all down 1. So -1, 0, 1, and 2. So what we've done here is we moved everything left, everything down 1. There I'm starting. Like that. So my other picture, oh, and by the way, it's plus or minus. So I got to do both of them. Like that. All right, so then for my other one, we're just going to switch everything. So -1, 0, 1, and 2. -3, -2, 1, and 6. So we're just another way to see it is reflect across this line. So this one looks like this. I'm thinking this one's going to be up like a cup. So -1, -3. 0, -2, 1, 1, and 2, 6. And then other way around 2. So there we go. Got our little parabola right there. Okay. Now algebraically, it kind of works the same way. First switch x and y. Get y plus 3 minus 1. First thing I'm doing, I got to get y by itself. This minus 1 is, impeding that. So x plus 1. Don't worry about the plus or minus. The next thing we're going to do is just square both sides. So we're just going to square this side, square this side. Now when we square a positive number or a negative number, it doesn't matter. It's still positive. So that's why we don't have to worry about that anymore. And it's just y plus 3. Last thing, if I want to get y all alone, we got to move this guy over here. So I got x plus 1 squared, then minus 3. Cool, right? Number 5 might be worth doing. Yeah, probably need. Let's do number 6 instead. That's a little trickier. So this is dealing with cubic. So y equals x cubed for this one. I'll do this table in black first. So that one is you're cubing all your x's. So we use those same x's again. So this is -8. This -1, excuse me. 0, 1, and positive 8. So the x's are going to stay the same for this picture. -2, -1, 0, 1, and 2. For my y values, though, the negative sign flips it. So now this becomes positive 8, and I subtract 2. So 6. Positive 1, subtract 2. Now it's back at -1 again. 0 would be down -2. 1 becomes -1, subtract 2, that becomes -3. 8, make it negative, -8, subtract 2, -10. So I have -2, positive 6 up here, -1, -1, 0, -2, 1, -3, and 2, -10. So my picture, yep, sure enough, is a neat little cubic. So when I flip all these, 6, -2, -1, -1, -2, 0, -3, 1, -10, 2, when I flip all these, I should get a picture of a cube root. Let's see if I did it right. Yep, it's reverse. Normally our cube root looks kind of like that, right? Well, because it's negative, it's flipped. All right, so let's solve algebraically. X equals -y cubed minus 2. Add 2, so x plus 2 equals -y cubed. Next thing I got to do, I got to get rid of this negative, so it's going to be negative x plus 2 equals y cubed. Last thing, take the cube root, take the cube root. So y equals, and when we take the cube root, we don't need the plus or minus there, because we can take the cube root of any number. So cube root of -x plus 2, all underneath the radical. That's pretty much it, guys. Try 7, try 8. I believe I have 8 as the answer here, so pause it for 1 sec, and I'm going to get you 8. Let's see, I did it in another class here. Oh, that's pre-cal, I don't want to do that. There we go. There's 8. There's all my work, all that stuff. Good luck. See you tomorrow. Bye-bye.